Welcome to the distribution pan water depth experiment. The apparatus you can see in the range hood has water flowing in the top and out a small hole in the side, and the flow rate in the top and out the bottom obviously is the same, or the water level would be changing. Right now I've got the flow adjusted to 5 inches of pan depth to simulate optimal flow in a cooling tower, and what we're trying to demonstrate is that the lower the pan depth, the less the flow rate. So in this experiment, we see that going in the top at a certain flow rate produces a trajectory coming out of the hole in the bottom that hits the bottom ruler at about the 12-inch mark, 11.5 or 12 inches. So I'm going to now slow the flow rate in the top of the pan down and see what happens to the flow rate out the bottom and where it hits the ruler in the collection basin. Bear with me. I've adjusted flow rate now down to maintain a water depth of 2.5 inches, which is the lowest recommended by manufacturers these days. And you can see that the flow rate going in the top of the pan is substantially lower than at 5 inches of pan depth, and that the trajectory, the arc of the line, the drain coming out, is now hitting at about 7 inches of arc. So substantially lower pressure, lower flow rate coming out when the pan depth is only 2.5 inches. Okay, the flow rate into the top of the pan has now been adjusted to maintain an equilibrium level of 1 inch in the distribution pan, in the blue pan. And you can see that the flow rate going in the top is indeed quite a bit lower. And of course, the flow rate coming out the bottom is also quite a bit lower. It's hitting the ruler at about the 3-inch point, where at a pan depth of 5 inches, it was hitting the ruler at almost 12 inches. So the flow rate of water into the distribution pan has a marked impact on the flow rate out of the pan, not surprisingly, and that in turn impacts the distribution of water over the nozzles and over the spray mechanisms coming out of the bottom of the downcomers in the distribution pan, that is critical to dispersing the water over the top of the fill pack. At 1 inch of pan depth, we're getting substantially less distribution of water over the top of the fill, and that makes for not only drier areas at the edge of those distribution patterns, but also a thinner film going down the fill. And on tall towers or high-load towers, or towers operating at peak demand, that results often in significant evaporation and thinning of the film towards the bottom of the fill pack, and scale formation within the tower fill, where at a full flow or full pan depth or full thickness of water film on the fill, scaling in the tower fill does not occur. If you have any more questions, please do not hesitate to contact your Chardon representative. Thank you.